Hello everyone. Okay, so for today we are going to go with the chapter 4 straight away, which is about matrices. Okay, so first thing is we're going to go with what is the subtopic that we are going to go with the matrices. So first thing, we are going to go with how to identify the size of our matrices. The second subtopic is we're going to go with how to apply the additional or subtraction operation on the matrices. The third one is to apply the multiplication operation on the matrices. The fourth subtopic is about transpose matrices, inverse matrices, and the last one we are going to go with how to solve for system of equation using the Cramer's rule, which is for the inverse matrices. Okay, so first subtopic is about how we want to determine the size of the matrices. So let's say we have a matrices here. Okay, so we have A, B, C, D matrices here. So how we want to identify the size of the matrices? First, we need to calculate how many rows we have in our matrices. So rows always with a horizontal line, which is for the horizontally we have 1 and 2 rows, which means that our size for the matrix will be 2 by, and this time is how many columns we have. So columns, we're going to go with vertically, which is in our matrix now we have 1 and 2 columns. So meaning that we have 2 by 2 size of the matrix. Okay, now let us go with the first example. We want to determine what is the size of the matrix for 1, 2, 3, 4, 5, 6, 7, 8, 9 in example 1. So the same thing, we need to calculate how many rows we have. So for the rows, always go with horizontally. So we have 1, 2, and 3 rows, which is 3 by, now we're going to go with the column. So column, I'm going to representing the column with red color. So column, how many columns we have? So the same thing, we have column, we go with vertically. So we have 1, 2, and 3 columns, which means we have this size of matrix is 3 by 3. Okay, now let us go with the second example. So we have 1, 2, 3, 4, 5, and 6. So to determine the size of this matrix, so the same thing, we go with how many rows we have. So for the rows, always go with horizontal. So we have 1, 2, and 3 rows, which means we have 3 rows. So 3 by, now with how many columns we have? So column, again, vertically, so we have 1 and 2 columns, which means we have the size for this matrix is 3 by 2. Last one, for the example 3, we have 1, 2, 3, 4, 5, 6. Again, to determine the size for this matrix, calculate how many rows we have, which is rows for horizontal. So we have 1, 2 rows. So we have 2 by, then for the column, we have 1, 2, and 3 columns, which means the size of matrix is 2 by 3. So that is how we want to determine the size of matrices. Okay, now let us move on to the how to apply the operation for additional and also subtraction for the matrices. So first, we have here plus or minus the matrices. So we need to remember whenever we do the operation of plus or minus for the matrices, we can only apply the plus and minus for the matrices for the same size of matrices. So if you want to plus 2 by 2 size, we should only plus or minus with 2 by 2 size also. If we have 3 by 2 size, we can only plus or minus with also 3 by 2 size. So let's say we have the example here. So we have A, B, C, D, which is 2 by 2 size, and we want to plus or minus with a matrix. So we can only apply or plus or minus with the same size of the matrix, which is E, F, G, H. So if we are having plus or minus, so we need to plus or minus the value for each of the matrices with the same position, So for example, we have A in the first matrix, which is A is in the position of first row and first column. So when we want to plus or minus, we should also plus or minus in the second matrix, which is also having in the first row and also in the first column. So our value will come up with A plus or minus with E. So the same thing with other matrices. So the same thing goes with other value in the matrix. The same position plus or minus with the same position. So we are having here B plus or minus with F. So the same thing goes with other value, same position, plus with the same position, and we will come up with a value here. And last one we have D, same position with D plus or minus, we are having H. So our answer will become D plus or minus H. So note that after we plus or minus the same size of matrix with the same size of matrix, our final answer also will come up with the same size of the matrices. Alright, so now let us go with the first example. So first example, we can see that for our matrix 1, 2, 3, 4, we are having the size 2 by 2. So now we want to do the operation of plus. So when we do the operation of plus, we should have the same size of the matrix. So we can see that 1, 0, 1, 1, we are having also the size of 2 by 2. So they are having the same size, so we can plus or minus. So again, after we add or minus, after we plus or minus, we will come up with the answer of the same size of the matrices, which is also 2 by 2. Okay, so we go with the first value. So the first value, 1 in the first matrix. So we need to plus with the same position of the value in the other matrix, which is also 1. So in our answer, we will come up here with 1 plus 1. Okay, for this one, I'm gonna go with the blue color just to represent with the same position. So we have here 1 plus 1. Okay, and then the second position, I'm gonna go with the red color. So the second position in the first matrix is 2. The same position in the second matrix is 0. And since we are doing for plus, so in our final answer we will come up with 2 plus 0. The third position, I'm going to go with the green color. So I'm having here 3 with the same position is 1. So 3 plus 1. And then the last position, orange color. So we are going to go with 4. Same position is 1. Means that 4 plus 1. So that is our answer. But please don't, this is not the final answer. Why? Because we need to simplify for each of the value. So for our final answer, we can see that 1 plus 1 here, we have 2. 2 plus 0 here, we also have 2. 3 plus 1 here, we have 4. And 4 plus 1 here, we will have 5. So this is our final answer. Okay, now let us go with the second example. So second example, we can see that we are doing for minus. So again, minus or plus, we need to do for only same size matrices. So if we can see that our matrix for the first one here, we have 2 rows and we have 3 columns, meaning that our size for the matrix is 2 by 3. So the second matrix also we have 2 rows and 3 columns. So we have 2 by 3 size of the matrix. So when we have the same size, we can minus. So the same thing, when we are doing the minus or plus, we need to only minus or plus for the value with the same position. So our final answer will come up with, for the first one, we have here 1 minus with 1. So 1 minus 1, we will come up with 0. Why we do minus? Because we are doing the operation of minus. Okay, for the second position, we have here 0 minus with 0. So 0 minus 0 is also 0. The third position, we have here 1 minus with 2. So 1 minus 2, we will have negative 1. Then for the next position, we have here 2 minus with negative 1. So 2 minus negative 1, we will come up with 2 plus 1, which is our answer will come up with 3. Next position, we will have here 0 minus with 0. Again, 0 minus 0 is 0. And last one, we have here let me choose for the color first. So I'm gonna go with purple. So the last position, we have here 1 minus 1. Again, 1 minus 1, we will have 0. Okay. So this is our final answer. So that is how we want to apply the operation of plus or minus for the matrices. Okay, we're done with the second subtopic. Okay, now let us go with the third subtopic, which is about multiplication for the matrices. Okay, so we have two types of the multiplication for the matrix. The first type is we want to multiply our matrix with a value. Okay, so we want to multiply a matrix with a value. So, for example, we have here, let us consider X here is a value. And we have the matrix of A, B, C, D here. So whenever we multiply a matrix with a value, meaning that the value we need to multiply with all the value that we have inside of the matrix. So we will come up with the answer, which is AX, BX, CX, and DX. So note that whenever we multiply with a value with a matrix, we will come up with the final answer, which is the same size of the matrix that we have. So if you can see here, we multiply X, which is a value, with 2 by 2 matrix. So our final answer also will come up with 2 by 2 size of matrix. So let us go with the example. So let's say we have here the first example, 3 multiplied with the matrix of 1, 0, 1, 1. So we multiply 3 with all the value we have inside of the matrix, meaning that we have here 3 multiplied with 1, and we also multiply 3 with 0, we also multiply 3 with 1, and we multiply 3 with 1. So we simplify the answer. We will come up with 3 multiplied 0 is 0, 3 multiplied 1 is 3, 3 multiplied 1 is 3. So that is our final answer for 3 multiplied with the matrices 1, 0, 1, 1. Okay, now let us go with the second example. So the same thing, we can see that we have 1 over 2 multiplied with the matrix. So when we have a value multiplied with a matrix, we need to multiply the value with all the value we have inside of the matrix. So for this final answer, we will come up with 1 over 2 multiplied with 2, we will come up with 1. The second position, 1 over 2 multiplied with 4, we will come up with 2. The third position, 1 over 2 multiplied with 6, we will have 3. Fourth position, 1 over 2 multiplied with 8, we will have 4. Then we have 1 over 2 multiplied with 10, we will have 5. And last one, we have 1/2 multiplied with 12, we will have 6. So that is our final answer. So note that our original matrices are having 3/2 size. So the same thing goes with our final answer. We also having 3/2 size of matrix. So that is the first type of multiplication, matrix multiplied with a value. Now let us go with the second type of multiplication, which is matrix multiplied with also matrix. Okay, so whenever we are dealing with the multiplication for matrix with matrix, we need to first consider what is the size of our matrix. So the rule of multiplication matrix with matrix, we should have the same value of the first matrix of the column. Sorry, I will represent this with a red color. Okay, so we need to look at the first matrix column, which is 2. This one should have the same value of the second matrix row, which is also 2. So if they are having the same value, so then we can multiply. So after we multiply, the size of our answer will become the value of the first matrix row and the second matrix column, which is we have here 2 and we have here 3. So that is the size for our value of the matrix. Okay, so how we are doing the multiplication? So what we are going to go with is, for the first matrix, we go with the row. The second matrix, we go with the column. So meaning that the first matrix, we go with the row. The second matrix, we go with the column. Which means A multiply with E and plus with B multiply with H. Then we go with also the row with the second column. So the first row, we go with the second column. So we multiply A with F plus with B multiply with I. So always go with plus. And then the last one, we go with the first row. And then we go with the last column, which is G and J. So we always go with A multiply with G plus with B multiply with J. Okay, I'm so sorry, I need to replace this one. This one is actually J. Whatever K that we have is actually J. So let me change here. This one as K. Okay, so that you won't confuse at the final answer here. So we will have here B multiply with K. So after we done with the first matrix, first row with every column in the second matrix, and then we go with the first matrix, second column. First matrix, second column, which is C and D. So the same thing, we go with second row for the first matrix with all the columns in the second matrix. So first we go with CD multiply with the first column, which is E and H. So we will come up with C multiply with E plus with D multiply with H. After that, we go with the second row with the second column. So we will have C multiply with F plus with D multiply with I. And also the last one, we have here second row with the last column. So we will have C multiply with G plus with D multiply with K. So it's a G here. Okay, so that's how we are doing for the multiplication matrix with matrix. So now let us go with the first example. So first example, we can see that for our first matrix, we are having size 2 by 2. second matrix we are also having size 2 by 2. So if we can see that if we want to do multiplication, we need to look at the first matrix column and second matrix row. So they are the same. So we can multiply these two matrices, which is the size of our final answer will become 2 by 2 size. Okay, now let us go with the multiplication. Alright. Okay, so first thing we go with the first row for the first matrix, which is 1 and 0. So we need to multiply with the first column in the second matrix, which is 1 and 3. So what we will have here, 1 multiply with 1, which is we have 1 multiply with 1, and we always need to plus with 0 multiply with 3, 0 multiply with 3. Okay, after we're done with the first row with the first column, and later we go with the first row with the second column. So second column we have here 1 multiply with 2. So we have here 1 multiply with 2, and we always need to go with plus, then the second value, which is 0 multiply with 4. So 0 multiply with 4. After we're done with first row with all the columns, and then we go with the second row, multiply with all the columns. So first we go with the first row. Second row with the first column. So we have here 1 multiply with 1. So we have 1 multiply 1. Always go with plus, and 1 multiply with 3. So we have 1 multiply with 3. Last value, so we have here second row for the first matrix with the second column for the second matrix. So we have 1 multiply with 2. So we have 1 multiply 2. Always go with plus, and 1 multiply with 4. 1 multiply with 4. So that's going to be our matrix. So we always need to simplify for our final answer. So we will come up with the answer here, which is 1 multiply 1 plus 0 multiply 3. So we will come up with 1. Second position, 1 multiply 2 is 2 plus 0 multiply 4, which is 0. So we will come up with 2. Third position, 1 multiply 1, which is 1, plus with 1 multiply 3, which is 3, so we will come up with 4. And last value, last position, 1 multiply 2 is 2, plus 1 multiply 4, which is 4, so 2 plus 4, we will come up with 6. So this is actually our final answer. So note that our size for the final answer, we will have 2 by 2 size, which is we have 2 by 2. Alright. Okay. Now for the second example. So I will erase the first example answer because I need more space. Oh, okay. Actually, I have the same value. Okay, I will just use this space. Alright, so if you can see that for the second example, we have 3, a value, multiply with the matrix. And we have 2 matrices here. So, the first matrix here, with the second matrix here, if you can see that we have size 2 by 2, multiply with size 2 by 2. So, whenever we can multiply the matrices with the matrices, and we multiply also with the value, always go with multiply the matrix with the matrix first, and then we multiply with the value. So first we have here matrix 1 0 1 1, multiply with matrix 1 2 3 4. So always multiply the matrix with the matrix first. Then after that, the answer we multiply with the value. So if we can see that the value of our matrix here is the same with the value of our example 1, so we can straight away come up with the answer, which is 1, 2, 4, 6. So meaning that what we have here is we are having 3 multiply with the answer of 1011 multiply with 1, 2, 3, 4, which is 1, 2, 4, 6. So we multiply 3 with 1, 2, 4, 6. So then we can see that we multiply a matrix with a value, so meaning that we multiply the value with all the value inside of the matrix. So we will come up with the answer of 3 multiply 1, we will have 3. 3 multiply 2, we will have 6. 3 multiply 4, we will have 12. And 3 multiply 6, we will have 18. So this is our final answer for 3 multiply matrix 1011 multiply matrix 1, 2, 3, 4. Okay, so that is for the subtopic of multiplication, the third subtopic. Now let us go with the fourth subtopic, which is about the transpose matrix. So transpose matrix is whenever we have the sign or the value or the letter capital T represented here. So whenever we have this capital T represented here, meaning that we are doing for the transpose matrix. So whatever transpose matrix that we have, so whatever of the row that we have in the matrix, it will become the column. Which is, if we can see that the first row in the matrix we have is AB. So now after we transpose, this row of AB will become the column of AB. And the second row, which is CD, will become the second column in the transpose. That's all. So let us go with the example. So if you can see that here we have 1, 2, 3, 4, and then we have the sign of capital T here. So meaning that we want to do for transpose matrix. So transpose matrix, the first row will become the first column, second row will become the second column, third row will become the third column, fourth row will become the fourth column, and so on. So we only have 2 rows, meaning that our transpose will become 2 columns. So the first column that we have here, the first row that we have here is 1, 2. So this one will become the first column. So column we go with vertically. So we have here 1, 2. The second row we have is 3, 4. So the second row will become the second column, which is we have 3, 4. So this is our transpose matrix. Now let us go with the second example. So the same thing, we have 3 rows here, so we're going to have 3 columns. So for the second example, we have the first row is 1, negative 1. So first row will become the first column, which is 1, negative 1. The second row will become the second column, so 0, 0. And the last row will become the last column, which is 2, 1. So this is our transpose matrix for 1, negative 1, 0, 0, 2, 1. So this is our answer. So that's it about the transpose matrices. Let us go with the next subtopic, which is next subtopic is about inverse matrices. So how we want to identify that we are doing for the inverse matrices is whenever we have here the exponent of negative 1 for the matrix. Whenever we have the exponent of negative 1, so we know that we are doing for the inverse matrix. So when we are doing for the inverse matrix, the formula given here to us is 1 over AD minus BC multiply with the matrix of, we change the position of A and D and we add the negative for B and C. We change the D and the A, the position, which is here, we change the position. And then for the B and C, position B and C, we put the negative sign. We multiply with negative. So that's the formula for inverse matrix. So now let us go with the first example. So first example, we have the matrix of 4, 3, 2, 1, and we can see that we have here exponent of negative 1, meaning that we are going to go with the inverse matrix. So inverse matrix, our answer, we will have first part, which is 1 over AD minus BC. So always we have 1 over with A multiply D, B multiply C. So AD in our matrix is 4 multiply with 1. That is AD. So 4 multiply with 1. Always go with minus. So we have here minus. And then for BC, so for BC, this is our position of B and C, 3 and 2. So 3 multiply 2. And then for our matrix, for the position of A and D, we're going to change them. So now will become 1 and here is 4. And for the BC, we need to multiply with negative. So negative, we will have negative 3. And for the 2, we have negative 2. So this one. Okay. Now we can see that here for this part, 1 over 4 multiply 1 minus 3 multiply 2, we will have 1 over negative 2. So 1 over negative 2 is the same with we have negative 1 over 2. So multiply with the matrix that we have 1, negative 3, negative 2 and 4. So to simplify this matrix, so a value multiply with the matrix, so we multiply with all the value we have in the matrix. So negative 1 over 2 multiply with 1, multiply with 1, so we will have negative 1 over 2. Negative 1 over 2 multiply with negative 3, so we will come up with positive 3 over 2. And negative 1 over 2 multiply with negative 2, we will have positive 1. And last one, we have here negative 1 over 2, multiply with 4, we will have negative 2. So this is our final answer for the inverse matrix. Now, the same thing goes with the example 2. So for the example 2, we can see that we have the exponent of negative 1. So the exponent of negative 1, so we know that we are doing for the inverse matrix. So inverse matrix, so the same thing, we will have here 1 over A multiply D, which is 1 multiply 1. We will have 1. Always go with minus. And then B multiply C, which is B multiply C is 0 multiply 1. So 0 multiply 1, we will have 0. Any value multiply 0 also will come up with 0. And then inside of the matrix, the position of A and D will be changed. So since that coincidentally we have both values the same, so we also will have 1 and 1. And then we need to put negative for the value of B and C. Since our value of B is 0, negative 0 also will come up with 0. And then for the C position, which is 1, so negative, put negative on the y, we have negative 1. So for this part, if you can see that 1 minus 0 for the denominator, we have 1 minus 0, we also come up with 1. So 1 divided with 1 also we will come up with 1. So 1 multiplied with every value also we will come up with the same value. So our final answer will come up with 1, 0, negative 1, 1. So this is our final answer for the inverse matrix for the second example. So please note that for the inverse matrix, we can only apply the inverse matrix only for the 2 by 2 matrices. So that is for the inverse matrices subtopic. And now for the last part of the matrices, which is we need to solve the system of equation using Cramer's rule. So for our syllabus, for the solving system of equation using Cramer's rule, note that we only apply for the size of matrix, which is size 2 by 2 for our syllabus. So what we want to find is whenever we talk about solve system of equation, meaning that we want to come up with the value of our variable. Whenever we talk about solve means that we want to know the value for our variable. And when we talk about system of equation, we will always have two unknown or two variables that we want to come up with a value. One variable, which is one is x, another one is y. So the formula to come up with x is dx over d. To come up with the value of y is dy over d. So meaning that in this situation, we need to come up with three values, which is dx, dy, and d, so that we can come up with our value of the variable x and y. So first thing that we need to do whenever we are doing for the Cramer's rule for 2 by 2, first step that we want to do is we need to always rearrange our system of equation. For our linear equations, we always will have two linear equations. So always rearrange our linear equations into the standard form of linear equation, which is the standard form of linear equation given to us is ax plus by equals to c, which means all the value of x and y should be on the left side. On the right side, only the value without the variable. So that is the standard form of linear equation. So after we rearrange into the standard form, so the second step is we need to put our linear equation or system of equation into the matrices form. So after we rearrange and put it into the matrices form, the third step is we need to use AD minus BC to find the value for D, dx, and dy. So that is the step for doing Cramer's rule. So now let us go with the example. So let's say the first example that we have here. So we can see that here we have two linear equations given to us, which is the first linear equation is negative 6x plus y equals to negative 11. The second linear equation is negative 2x minus 3y equals to negative 7. So first thing is we need to make sure that both linear equation is in the standard form of linear equation. So if we can see that here, both of the equations already in the standard form, which is both of the equation is in the form of ax plus by equals to c. So after both already in the standard form, and then we can go with the second step, which is we put our system of equation for both linear equations into matrices form, which is we always take the value only. So for example, we have here the first equation, we have negative 6 for x, we have a value of 1 for y, which means we have here negative 6 for the x. We only take the value. We have value 1 of the y, and we have value negative 11 for the c. So the second equation, we have negative 2 for the x, we have negative 3 for the y, and we have negative 7 for the c. So first equation will be first row, second equation will be second row. So in the matrix form, we will have here as negative 6, positive 1, negative 2, negative 3, and we have here negative 11 with negative 7. Okay, so that's the second step, which is we are putting the system of equation into the matrix form. Okay, now the first value that we want to come up with is the D. So when we want to come up with the D value, so we just take this matrix, which is we have here -6, +1, -2, -3. So we want to apply A, D minus B, C. So what we will have here, so this is A, this is B, this is C, this is D. So the formula is AD minus BC. So what we will have here is A multiply D, which is -6 multiply -3. -6 multiply -3. Then we have minus. Then B multiply C, which is 1 multiply -2. +1 multiply -2. So -6 multiply -3, we will have 18. Minus with 1 multiply -2, we will have -2. So our value for D will be 20. Okay, so that is for the D value. Now, moving on to the value of the second value that we need to come up with is the value of dx. So when we want to do for dx, we need to take the second matrix here, substitute into the x column, which means we know that the x column is the first column here, is the value for the x. So we substitute into the x here, so our matrix will come up with -11, -7, then we will have here 1, -3. Substitute into x column. So the same thing, we want to come up with the dx value, so we need to apply AD minus BC. So the same thing, A is -11, B is 1, C is -7, D is -3. So AD minus BC, we will have -11 multiplied with -3 minus with 1 multiplied with -7. So we will have here -11 multiplied with -3, we will have 33. Minus with 1 multiplied 7, we will have -7, which is 33 minus -7, we will have 40. That is for the dx. And then I'm gonna go with the dy. So dy, so last value that we need to come up with is dy. So the same thing for dy, we need to substitute this matrix into the y column, which is here. So we will have the matrix which is -6, -2. We substitute into the y column, we will have -11, -7. So the same thing, to come up with dy, we need to use AD minus BC. So what we have here, -6 multiplied with -7, which is we will have 42, minus with -11 multiply with -2, which is we will have 22. So 42 minus 20, our value of dy will be 20. So after we have all these d, dx and dy, so we know that our d value is 20. here, our dx value is 40, which is we calculate just now here, 40, and our dy is 20, which is here, 20. Now we can calculate the value of our x and our y, which is x value given the formula, which is dx over d, which is dx is 40 and d is 20. So 40 over 20, we will come up with 2. And then for the y, we have dy over d, which is our dy is 20 over d, which is d is also 20. So 20 divide 20, we will have 1. So this is our value of x, this is our value of y. So we solve this system of equation using the Cramer's rule. Now, let's say we have another example to solve the system of equation using Cramer's rule. So let's say we have second example. So it's given to us negative 3x equals to 3y plus 3. Second equation given to us is 5x plus y equals to negative 17. So we want to solve this system of equation using Cramer's rule. So first thing, we need to rearrange, or we need to make sure both of our equation is in the standard form. So we look at the first equation given to us. So the first equation is not in the standard form, which is we have 3y on the right side. So we need to move this 3y to the left side to make it in terms of the standard form. So when we move 3y to the left side, it will become minus 3y. So we will have here negative 3x minus 3y equals to 3. The second equation is already in the standard form, so we don't need to rearrange. So we just write it down again. So 5x plus y equals to negative 70. So after we rearrange, so we put them in form of standard form. In form of the matrix. So our matrix we will come up with, only take the value. So we have negative 3, 5 and 1. And the second matrix we have here is 3 with negative 17. So do the same thing. To come up with the first value, we need to have d value. So d value, just take the first matrix. So we have here negative 3, 5 with 1. So apply the rule of AD minus BC to come up with the value. So AD is negative 3 multiply 1, minus with BC, which is negative 3 multiply 5, so we have negative 15. So negative 3 minus negative 15, we will have positive 12. So that is our D value. The second value that we want to come up with is dx. So dx, we need to substitute the second matrix into the x column, which is x column is the first column. So we substitute into the x column, we will come up with 3, negative 17. Then the y, we are using the original value, so we have negative 3 with 1. So the same thing, we want to come up with the value of dx, use the rule of AD minus BC So AD, which means 3 multiply 1, so we will have 3, minus with B multiply C, which is negative 3 multiply with negative 17, we will have positive 51. So 3 minus 51, we will have negative 48. And last value, we want to come up with a dy value. So dy, we substitute the second matrix into the y column. So we will come up with, first column we use the original one, negative 3 with 5. Then we substitute the second matrix into the second column, which is the y column. So we will have 3 with negative 17. So the same thing, use AD minus BC. So AD, which means negative 3, multiply with negative 17. So we will have positive 51. Minus with B multiply C, which is 3 multiply 5, so we will have 15. So 51 minus 15, we will have 36. So after we have all these three values, so then our D value is 12. Our dx value is negative 48. And our dy value is 36. Here, d value, dx value, and dy value. So now we want to come up with our variable value. So variable, the first variable is x. Formula given to us is dx over d. So our dx is negative 48. Divide with d, which is 12. So negative 48 divide 12. So we will come up with negative 4. Then for the y value, formula given to us is dy over d. Dy value is 36. Divide with d, which is 12. So 36 divide 12, we will come up with 3. So that is our value for our variable using Cramer's rule. Okay, so basically that is the only subtopics that you need to learn about the matrices chapter, which is chapter 4. So with the end of the slide here, so basically we've done with chapter 4. So please look at the online individual assignment. So the online individual assignment 3 is for the chapter 4, and everything is only A, B, C, D. So you just need to click. So please make sure watch the video first, and then you can answer the question. Okay.